Hey y'all, welcome back to the lab. In this video, we're talking about Advent of Code 2024, Day 4, solved with F#. So as a reminder, Hominions members do get full access to the project files, so you can get clone and run it yourself, but I'll be showing all of the source code or logic source code here as well, if you just want to copy and paste it. Alright, so Day 4, Part 1. So the prompt is here, but we'll just go over my summary of this. So basically we're given a grid of letters and the ask is to count all instances of Xmas. So basically this string all in a row in the grid. And so all of these are going to start with X. And so basically, we're counting the multiples of X with, corresponding mus. So you can use X multiple times. And these can be horizontal, vertical, diagonal, backwards, or overlapping. So you can reuse letters, but they can be, all 8 cardinal directions or whatever. Now note that I thought this meant that characters could be sneaking. So it could be like XMAS, it could be a snake. But this is actually not true. What they're actually asking for is Xmas in a single direction. And so this wasted a lot of time for me because I was going all like recursion and check all possibilities. So read the prompts closely because I definitely did not do that for this one. So my solution after realizing this was to basically iterate over all the grids and then find all X's. We know that each Xmas has an X. It starts with an X, so we can just use that as there might be Xmas's here. Let's count all of them. And then basically what I do is I generate all possible directions. So it's going to be 8. It's going to be all the diagonals and all the vertical horizontals. And then I find their potential coordinates, which is a little confusing maybe, but I wanted to try this approach out. And then I basically just check if the coordinate equals the expected character. At the end, I sum all of the matches from the 8 directions, and then at the end, we're adding the total after iterating over the entire grid. And so we're hitting all possibilities. We're only doing the expensive stuff when you find an X, and there might be a possibility here. So worst case, this is n times 8 times 4, which basically ends up being n. So the code's here if you're going to copy and paste it, but I'll also open it up in my editor. All right, so here's Day 4. Got a lot of helpers here, but let's start at the solution, then we'll dive into the helpers. So basically we're taking in the file name. I found this is a pretty easy approach to try for the debugging versus the real input, and the debug input is useful to solve first so that you don't do the dumb thing that I did earlier. And so you just read out all the input lines, and then we basically turn this into a grid of letters. So I just get each of the input lines, I map over them, I turn them into character arrays, and then I map those to just make sure that they're strings, and then I make sure that I turn these back into arrays. So I've got a 2D string array basically. And then I'm just keeping a running total up here, then iterating over the y and x of the grid, and then I call my helper function here to count all matching words from the start position. I give it the grid, I give it the xy coordinate it's searching at, and then I give it the thing to match on, and then I add the total, or add, however much we find here to the total. So that's how it works. And then let's go into this because this is really doing all of the work. And so, basically what it's trying to do is find all the possible directions, then get all the letter positions in that direction. Then it's going to check each letter against its position to see if it's correct. So, X at 0th, M, A, S, like that. And then if all of those match for that set of coordinates, then it's going to return a true, and then we'll count the trues at the end. So that's basically what we're doing. So the first thing we do is we generate all relative grid values. This is a little complicated. It didn't really need to be that, but basically we're just finding all combinations of -1, 0, and 1 against itself. So we map over this, and then we map over this again to get xy coordinates, and then we just remove 0, 0 because we don't need 0, 0, and so that's how we get all 8 relative coordinates that actually move us around the grid. So we generate those. And then now that I have the xy coordinates, which are relative, I'm going to multiply those by the magnitude of the index. And so basically this is to get all coordinates of the rows. And so I'm saying, for the first letter, which is our x, we want that to actually match against where we are on the grid. And so its relative position is just going to be 0. And so we're multiplying these here. Then at 1, we need it to go 1, and then 2, and then 3. And then so that's how we are doing this. And so now I've got a list of all coordinates in a single possible word. So for each 8 directions, I have all the potential coordinates for that for each of the words, which allows us to then map over this. We grab the iterator here, and then we say for all, which is basically checking that everything in this is true, and it will early return if anything is false. So for all of these coordinates, we're just checking, hey, is this coordinate equal to, the ith value in this word? And so, it'll check that our position is x, and then the next one is m, and then a, and then s, and then, so forth. If any of them are not, then this will return false, so we won't count it. But if they all are, then we found the full word, and so we will count it as true. And then we filter to just the trues, and then we get the length. And so that's how we're getting the sum of this. A little complicated, but I was trying to figure out how I could just do all of this with a bunch of pipes. And this is what I came up with. Another thing to note is, what is this thing here? Basically, it's just a helper to say, like, if we're outside of the grid, return false. Because it can't be a match, and this also keeps us from having to do like exception error handling or anything. But if we are inside the grid, then it'll just match the 2 match, and so this is just a nice helper for doing that. And so that's how I solved part 1, and it was accepted. We can see here, accepted. And now we're on to part 2. So here's the prompt, and basically it's the same input as above, but now we want to count all MAS in an X shape. And so basically it has to be MAS one way and MAS the other way, although the order, or I guess direction of the MAS each way doesn't matter. It just has to be in an X shape, and it has to, be MAS. This one actually seems simpler than the original one, and basically there's 2 subproblems here. One is finding all possible X's, and we know that all of them must have an A in the middle, and so we can just kind of do the same thing we did above with the X's here with an A. So we just find all of those, and then we look to see if there are matches there. And then determining if we found an X, there's like clever ways to do it, but honestly, there's only like 8 checks, I think. 2, 4, 8. 8 checks, and so, we can just kind of write it all out here. It's not gonna matter so much, and basically we just check, both the cross-section this way and the cross-section this way, and it needs to be in MNS this way or MS this way for each one. If that exists, then we just mark it as true. If both are true, then, we found an X. So here's the code, and we'll open it in the editor. So here's solving part 2. Looks very much the same. We get the letter grid out. We're looping through the grid, and then we're just pulling out, if this is an Xmas here, then we set it to 1 or 0. This looks a little weird. I was just doing this for debugging purposes. It's easier for me to have an intermediate variable and then print out, but, you could imagine this could probably just be like a sum by or something like that. But this is what we got, and so really, iterating over the grid, and we're just calling this one helper function to help us, is Xmas. So this is taking the grid and the XY value, and we are currying this guy just because we don't want to have to pass in the grid each time because it's just annoying. And so this just curries it to make sure that it has like a closure on grid, so we just have to call it with its XY to match values. And so we can see it shortens it here. And then we're just like, hey, if this current character is not A, then we know this can't be a grid, so we'll just say no. And then our outer loop can keep looping. And then we just check the left slash and right slash. And basically we're like, upper left, bottom right must be MS, or it has to be the opposite where it's SM. If one of those are correct, then we found MAS in this version. And then right slash is this way, X plus 1, Y minus 1. So it's just MS. If not that, then it must be MS this way. And if it is, then we've got right slash. And then if both of those are like correct, then we'll return true. And so that's how we're counting all of these. Yeah, nothing more to say on this one. I think this one was a little bit more straightforward than the last one, at least writing it with F# and some of these like list helpers. So pretty happy with how it turned out. Yeah, if you like this, check out some of my other Advent of Code solutions. They will be linked here in this tag. And that's it for this video. Thanks for watching, and I'll see you in the next one.